Today, we're going to dive deep inside your computer, your phone, pretty much every smart device you own. We're going to uncover the single most important piece of software running on it, something that's so good at its job, you probably don't even notice it's there. Let's get into it. So let me just ask you straight up, what do you think is the most important program on your computer? Is it your web browser? Maybe your favorite game? A word processor? It sounds like a simple question, right? But the answer is the key to how everything, and I mean everything, works. And the answer, of course, is the operating system, the OS. It's the very first thing that wakes up when you turn your device on and the absolute last thing to shut down. It's the invisible genius that turns a simple box of electronics into a machine you can actually use. So, what does an OS actually do? Well, think about it like this. Without one, a computer is just a really expensive paperweight, just an inert collection of circuits and wires. The OS is the master controller, the conductor of the orchestra, that brings all that hardware to life and makes it a useful tool. You know, what's really interesting is that an OS kind of has two different personalities. From your point of view, the user view, its main job is just to make things easy, giving you those nice icons and a mouse pointer. But from the computer's perspective, the system view, it's the super strict resource allocator. It's a control program that manages every single resource from CPU time to memory, making sure every other program plays by the rules. Okay, let's tackle the first big magic trick, multitasking. Now, your computer's main processor, the CPU, is unbelievably fast. But here's the catch. It can technically only do one thing at a time. One single thing. So how in the world can you browse the web, listen to music, and chat with a friend all at once? Well, the answer is this really clever technique called multi-programming. The OS loads up several programs into the computer's memory all at the same time. It's basically lining them up so the CPU never has to sit around doing nothing. There is always another job ready and waiting to go. And this is how it pulls off that magic trick. The OS is a master of illusion. See, a part of it, called the scheduler, gives each program a tiny little time slice. We're talking just a few milliseconds of the CPU's attention. Then it switches to the next program, and the next, and the next. It does this hundreds, even thousands of times a second. It happens so fast that it creates this powerful, totally convincing illusion that they're all running at the same time. So it's not actually parallel, it's just incredibly fast switching. All right, let's move on to the next big problem the OS has to solve. I want you to picture your hard drive. At its most basic level, it is just a huge, disorganized space for storing ones and zeros. Without an OS, it would be like a digital warehouse with no shelves, no labels, you'd never find anything. The OS steps in and brings order to all that chaos by creating the abstract idea of a file, just a named collection of related information. That document, that photo, that song. They don't actually exist as neat little objects on the disk. They're just concepts, ideas, created and managed entirely by the OS's file system so we can make sense of it all. And to manage all these files, the OS provides a super simple set of commands, kind of like a universal language for data. Every single application on your computer, from a simple text editor to a massive video game, uses these same basic operations: create, read, write, delete, to talk to the hard drive. And the OS handles all the messy, complicated details in the background. Okay, so we've got multiple programs running at once, and we've got a structured way to store our data. But with all of that happening, and with a connection to the internet, how does the OS keep everything safe? How does it stop one rogue program from crashing the whole system? This brings us to the OS's role as the digital guard. It has to enforce a really strict set of rules to defend the system from attacks from the outside, and even from programs on the inside that start misbehaving. It manages permissions, separates important operations into a protected kernel mode that normal apps can't touch. It's a tough job. Let's look at a few of the threats it's always dealing with. First up, the Trojan horse. This is a malicious piece of code that's hidden inside a program that looks totally useful. To fight this, the OS uses powerful techniques like sandboxing, which is like building a digital wall around a program to strictly limit what data and resources it's allowed to access. Next is the worm. This is a program that's designed to do one thing: copy itself over and over again across a network. A famous early one, the Morris worm back in 1988, spread so fast that it brought huge parts of the early internet to a grinding halt, simply by using up all the computer resources. And then you've got denial of service attacks. These don't try to steal your information, they just want to shut a system down. Basically, they work by flooding a computer with so many fake requests that it gets overwhelmed and can't respond to the real, legitimate users anymore. So these core ideas, managing resources, organizing files, and playing security guard, they aren't just for desktop computers. These same principles have been adapted and have evolved over time, and now they power every single piece of computing technology we rely on, from massive servers all the way down to the smartphone in your pocket.
And this whole evolution has kind of followed two major philosophies. On the one hand, you have closed source systems, like Microsoft Windows, where the internal code, the recipe, is a closely guarded secret. On the other hand, you have open source systems, like Linux, where that source code is totally public for anyone to read, modify, and even help improve.
And the story of Linux is a perfect example of the power of open source. It all started in 1991, just as a hobby project by a student in Finland named Linus Torvalds. He released his simple work out into the world, and thanks to the internet, a global community of developers all chipped in to help build it into the absolute powerhouse that it is today. I mean, it runs the majority of the world's servers, supercomputers, and, oh yeah, Android phones. So the next time you unlock your phone or boot up your laptop, just take a second to appreciate that invisible genius working tirelessly behind the scenes. It's a technology that's always evolving, which kind of leaves us with one final question to think about. As our devices get more and more tangled up in our lives, what new challenges, what new impossible tasks are we going to ask our operating systems to solve next?